Hi ladies, in this video we're going to go over the exam 1 revision sheet. This video is going to focus just on parabolas. There'll be another video for the probability and for the trigonometry sections, just to keep it short, or the video shorter, and also to enable you maybe just to have a little break in between and it's not so overwhelming listening to my voice for God knows how long this video is going to be. So let's keep it short with parabolas, and there'll be another 2 videos for probability and trigonometry. Okay, question 1. Find the equation of the parabola shown below. Express your answer in the form y equals ax squared plus bx plus c. So this is just what we call expanded form. So you can have factorized form and you can have turning point form, but we're just going to use the expanded form. Now, the problem I noticed the other day when students were doing this is they started with this equation, okay, and started substituting values in. Now, the good thing is you did notice that c should be -12, but then you're probably like, well, what do I do with the other 2 numbers? When it's in expanded form, you can't really substitute anything in. The best way is to actually get it in factorized form. So to get it in factorized form, we need to look at our x-intercepts. So our x-intercepts for this one is -1 and 3. So in factorized form, we're going to have x plus 1, x minus 3. So just notice the signs change because when we use the null factor law, so when we let it equal 0, x plus 1 equals 0, that means x equals -1. Now, the other thing you need to know is even though this is these are the factors, many parabolas can go through these 2 points. So what we need to do is put in the value of a, just so we know, well, what is actually happening to this parabola, okay? Because there's an infinite number of parabolas that can go through -1 and 3. So putting in this coefficient of a just enables you to say, well, I'm looking at the parabola that goes through this point, okay? So you're always going to be given enough information to do your parabola. So just make sure you use all the information given to you. So we were given the y-intercept, not the turning point. If we were given the turning point, okay, we could substitute that in as well, or we could actually just use turning point form. So one question coming up is actually we're going to be doing that. Okay, so this basically means x equals 0. So this point is x equals 0, y equals -12. So we're just got to substitute that into our equation. So we've got -12 equals a, 0 plus 1, 0 minus 3. And let's just tidy it up a bit. So a times, now the good thing is we can easily add 1 to 0, so it's 1 times -3. So -12 equals 1 times -3 is -3. And then divide both sides by -3. So a is equal to 4. All right, so we've got the value of a. We can substitute that back into our equation. Okay, so this equation here. So we've got now y equals 4, x plus 1, x minus 3. Now at this point, it's not in expanded form, so we do have to expand it. So let's go ahead and expand it now. So keep that 4 out the front for now and do your expansion. So hopefully you can expand it binomials by now. So x times x is x squared, x times -3, and then we're going to have x, so it's going to be minus 2x. 1 times -3 is -3. And now we put that 4 through everything inside the bracket. So 4x squared minus 8x minus 12. And there's your equation of this graph. Okay, question 2. Consider y equals -x squared plus 2x plus 3. So find the coordinates of the x-intercept. Your x-intercept is always when x equals 0, but in expanded form, it's always whatever your constant is. So our constant in this case is 3. because we're doing the coordinates, we've got to write 0, 3. Okay, so don't write y equals 3 because they're not the coordinates. The coordinates are 0, 3. Now, the coordinates of the x-intercepts. So we're going to have to factorize this to get the coordinates of the x-intercepts. So let's start with y equals. I'm going to take that negative out as a common factor, just so we're dealing with a positive coefficient of x squared. Okay, so forget about that negative out the front. We're just going to factorize what we have in brackets. So we need two numbers that multiply, give us -3, and add to give us -2. So we're going to have x minus 3, x plus 1. Okay, so -3 times 1 gives you -3. -3 plus 1 gives you -2x. Now, to get the x-intercepts, we use the null factor law. So let y equal 0. That negative is going to disappear, so we're effectively just left with x minus 3 equals 0, so x equals 3. And then x plus 1 equals 0, so x equals -1. So remember, we're doing the coordinates, so let's write the two coordinates down. We're going to have 3, 0, and -1, 0. Let's put that in a square bracket. Okay, the coordinates of the turning point. So there's two ways you can do this. Your turning point is halfway between your x-intercepts. And in this case, because we've done the x-intercepts, it's probably the easiest way. But you can also find your x-intercepts by doing x equals -b on 2a. Okay, so that will give you your x-coordinate of the turning point. So let's have a look at both of them. So the value of A is -1 and B is 2. So let's substitute them in. So B is 2 and A is -1. So we're going to have x equals 1. So -2 over -2 gives you x equals 1. Now, to get the y coordinate, we just substitute that 1 back in. So you can substitute the 1 back into your original equation. You can substitute it back into your factorized equation. It doesn't make any difference because effectively it's the same equation. One's just expanded and one is factorized. Now, just because the factorized version is still on my screen, I'm going to use that one. So this is what I'm using here. So x is 1, so I'm just going to put 1 in for x. Okay, don't forget that negative, it has to stay. So 1 minus 3 is -2, and 1 plus 1 is 2. So we're going to have y equals -2 times 2 is -4, and then you've got that negative, so it's going to make that a positive. So the coordinates there is 1, 4. Now, if you wanted to do it the other way, if we just have a look at our graph, we're going to have to graph it later anyway. So our x-intercepts are here at -1 and 3. So your turning point is always halfway between them. So you can see that it's going to be at 1. Okay, at x equals 1. If you can't work out the halfway point, so let's say you had non-integer values and it was just too hard to see what that middle value is, just add your two numbers together, so -1 plus 3, and divide by 2. So -1 plus 3 is 2, divided by 2 gives you the 1. Okay, and then you just substitute it back in as well. So x equals 1. Actually, I might not write that again just because I'm going to keep this sheet with the answers on it. So people might not know what I'm actually doing if I write anything else on there. So I'm just going to write 1, 4. And because we've got a bit of working out there, I'm going to put it in a square, okay, just so we know where the final answer is. All right, the axis of symmetry. The axis of symmetry is always halfway between. Okay, so we've already found out that the axis of symmetry oh sorry, our turning point is at 1. So your axis of symmetry is actually just the x-coordinate of your turning point. So it's x equals 1. Okay, sketch the graph showing all the above features. Okay, so if you wanted to put in, we've already got the axis of symmetry there, so I'm just going to write x equals 1. I've put in the x-intercepts. Let's put in the y-intercept. So it's at 0, 3, which is here. The turning point is at 1, 4, which is here. Now remember, parabolas are symmetrical, so I'm going to just put that point there just so it's a little bit easier to sketch. And you guys are great at sketching. Oh gosh, I say that as I draw very poorly. Sketch a very poorly drawn parabola, but that's pretty good. If you know, it's a bit hard doing it on a tablet. Okay, so there's actually, did I put the turning point on? No, I didn't. So I'm just going to put the turning point. Yeah, it's easy to see what the turning point is. Okay, but sometimes it's a good idea to label it. We can clearly see the intercepts. If it wasn't clear, so if you had a fraction or a non-integer value, so just label it would be best. All right, let's move on. Okay, so question 3, find the discriminant for 2x squared minus 7x minus 3 equals 0, and hence determine the number of solutions for this quadratic equation. Okay, so quadratics does link in with parabolas. So if you're thinking, oh, this is quadratics, I'm not going to see this, we do need this because remember, the number of solutions tells us how many x-intercepts we have on our graph of the parabola. Okay, so the first thing you need to do is identify A, B, and C. So A, B, and C are just the coefficients and your constant. So the coefficient of x squared is your value of A, the coefficient of x is your B, and then your constant is your value of C. Now the discriminant is equal to what in the quadratic formula, what is underneath the square root sign? So B squared minus 4AC. So we're just going to substitute everything in. Now, B is -7. Don't make the mistake of saying that's -49, because remember, when you square a negative number, and I might just tidy up that negative, you get a positive answer. So 7 squared is 49, but -7 squared is also 49. Okay, sometimes putting negatives in brackets reminds us of that. And then we've got -4 times A times C. So C is a -3. Now just take your time, because when people make mistakes, it's usually with their negatives, just small mistakes that are avoidable. So -7 squared is 49. Now we've got a negative and a negative, so now I'm going to get a positive answer. So 4 times 2 is 8, times 3 is 24. So 49 plus 24 gives me 73. So therefore, we have 2 solutions. So that means your parabola will cross the x-axis in 2 spots. Okay, so it has 2 x-intercepts. All right, question 4. A parabola has x-axis intercepts of -1 and 2 and passes through the point 3, 6. Find the equation of the parabola, expressing your answer in the form y equals ax squared plus bx plus c. So this is pretty much the same as the very first question. Obviously different values, and they haven't drawn the graph for you, but same information has been provided to you. So we have, x-axis intercepts of -1 and 2, and we're going through 3, 6. So writing our equation in factorized form, remember y equals a, because we don't know the dilation factor of this quadratics, and you know there's an infinite number of parabolas that go through -1 and 2. So I've got x plus 1, x minus 2. Now we're going to sub in 3, 6. So x equals 3, y equals 6, just to get that value of a. So 6 equals a, 3 plus 1, 3 minus 2. Okay, so 3 plus 1 is 4, 3 minus 2 is 1. So I've got 6 equals 4a, divide both sides by 4. How much space have I got down here? All right, I've got enough space to write the value of a. So a equals 6 over 4, which can be simplified to 3 over 2. Now we substitute that back into this equation. So we've got y equals 3 on 2, x plus 1, x minus 2. All right, so let's expand those brackets. So we're going to have x squared minus 2x plus x, so minus x, and then minus 2. And then we just multiply that 3 on 2 through. Now you can keep your coefficient out the front, or you can write it in another way, which I'll do in a sec to show you. And then minus 3 on 2 times 2. Okay, so just with that constant, those 2's actually cancel out. Okay, so you can write it as a coefficient like I have there, or you can write 3x squared on 2 minus 3x on 2 minus 3. Okay. All right, question 5. So because I just did this question, and when I got to the end, I realized I made an error. So I'm doing it for the second time. And it's a good, I didn't know whether to go back and show you what error I made. Basically, I got my turning point, the coordinates around the wrong way. And my equation at the end, it just didn't look right because I got a value of a, which was 5. And I knew that wasn't correct just by looking at it. So then I checked it on my calculator, and I know you can't do that on your exam, but it's always a good idea to check some way. So in that case, without the calculator, I would have gone back and maybe substituted a few points in just to see if it made sense. But basically what I did, if you're interested, I did my turning point as -1, -2. So I got my x and y values around the wrong way. So we all make mistakes, girls. You didn't see that mistake because I've already edited it out of the video. But it's extremely important to take your time. Okay, so anyway, question 5. I didn't even introduce the question. Sorry. Find the equation of the graph below. So this is this is similar to question 1, but different because we don't have the x-intercepts this time. We've got the turning point and the y-intercept. So what we need to do is use the turning point form, okay, which is this. Y equals a times x minus h squared plus k. So remember your turning point is at hk. So for this question, h is -2 and k is -1. So then we just substitute that into our equation. Now, because h is a negative, so a negative and a negative gives you a plus, so it's going to be +2 squared minus 1. Now we substitute in whatever other point we have. So we've got the y-intercept, which is 0, 3. I'm just going to scroll down so we've got a bit of space. Okay, so 3 equals a, 0 plus 2 squared minus 1. So we're going to have 4a minus 1. Add 1 to both sides. So they're left with 4 equals 4a. So a is equal to 1. So our equation is y equals 1, x plus 2 squared minus 1. So I'm just substituting it back into here. Now we don't tend to write a equals 1 there, so I'm just going to rewrite it. You didn't have to write the 1 there, but I just wanted you to see if you had a different value of a, that's where it would go. So there's our equation. And I'm a lot more comfortable with that being the right answer. All right, Okay, so there's probability, so that'll be in another video. All right, girls, bye.